Okay, let's consider y varies directly with the square root of x. Little different statement. What does that mean? Well, direct variation of y with respect to x means that y equals kx. So direct variation of y with respect to the square root of x would mean what? You can figure it out. Think about it. Well, it means that x has been replaced by square root of x, so we're going to replace it here by square root of x. Y is going to equal k times the square root of x. Now, if y equals 6 when x equals 25, don't look, work this out. What's the next step? Well, the next step is we write the equation with 6 for y and 25 for x, and here it is. Square root of 25 is 5, so we get 6 equals 5k. The solution is k equals 6/5. What do we do next? Figure it out. Think about it. Stop and think for a minute. Don't just watch. Well, okay, now, y then equals 6/5 times the square root of x. We've just substituted k equals 6/5. K is a constant. It's going to work for this equation. And now we have a rule. Y equals 6/5 square root of x. If I put in any value of x, I get the corresponding value of y. Now, if I let x equal 100, what am I going to get for y? Work it out. Well, x equals 100. Plug that in, get the square root of 100. 6/5 times the square root of 100 is 6/5 times 10, which is 12. Now, what's just happened? X increased from 25 to 100. X got 4 times as big. What did y do? Y went from 6 to 12. It only got twice as big. Why is that? Well, the variation is with the square root. The square root of 4 is 2. So when x gets 4 times as big, y will get square root of 4, or 2 times as big, which is exactly what happened here. Okay, now let's suppose that y varies inversely with x squared. What's our equation going to be? Y varies inversely with x squared. Well, if we look over here, we see that inverse variation of y with respect to x would be y equals k over x. So if we replace x by x squared, we would replace x here by x squared. We get y equals k over x squared. So now y varies inversely with respect to x squared tells us that y is k over x squared. Now, let's just say if y equals 10, when x equals 3, then what? What can we conclude? What are we going to do? Just pause, think about it. But okay, we're going to put the 10 and the 3 into this equation. We're going to say 10 equals k over 3 squared. And we can easily solve that. 3 squared is 9. Multiply that by 10. K equals 90. Now, if x equals, let's say, 6, actually, I'm getting ahead of myself. We want to write the equation y equals 90 over x squared. Now, if x equals 6, then what are we going to do? Now, why do we say y equals 90 over x squared? Well, y equals k over x squared. We just found that k is 90, so we're going to put that information into the equation. Now, if x equals 6, what happens? You can work this out. Go ahead and do it. You should have paused and done it, but we get y equals 90 over 6 squared. That's 90 over 36. That's 2.5. So what has happened here? Well, x went from 3 to 6, so x got twice as big. But this is inversely proportional to x squared. If x gets twice as big, x squared gets 4 times as big, which means y is going to get 1/4 as big. Well, y started at 10. What's 1/4 of 10? Well, it's 2.5. So y did get 1/4 as big. So you want to try to understand this, but the procedure is fairly straightforward, and you can solve the problems that you're going to see largely just by understanding what we mean by direct and inverse. Now, what do we do with something like this, where y varies directly as x squared and inversely with the square root of z? Well, y varies directly as x squared would be y equals kx squared. Inversely with respect to the square root of z would be k over the square root of z. We can combine these. We can just say, okay, y equals k times x squared over the square root of z. So now we have y varying directly as x squared and inversely with the square root of z. So if we have, let's say y equals 12, when x equals 5 and z equals 9, then what can we do? You should be able to figure this out. Pause and think about it. Okay, well, I'm going to just plug what we know in here. We've got a value of y, a value of x, and a value of z, so we can say, okay, well, y is 12, that's equal k times x squared, x is 5, that's 5 squared, divided by the square root of z, which is the square root of 9, and that's going to equal k times 25 over 3, so that k equals 12 times 3 over 25, which is 36 over 25. So now y equals 36 over 25 times x squared over square root of z. Now, if x changes, let's say x is 5, let's say x doubles, that triples, let's say x triples and becomes 15, and let's say that z quadruples and becomes 36, then what's going to happen to y? Well, y equals 36 over 25 times x squared, x is 15, that's going to be 15 squared, over the square root of z, which is the square root of 36. Okay, well, that's 36 over 25 times 15 squared is 225. Square root of 36 is 6. And you can figure out what that is, but it's easy. 6 goes into 36 6 times. 25 goes into 225 9 times. 6 times 9 is 54. Now we could say a few things about how these numbers compare and so forth, but really, if you just get the mechanics of this process, you're going to be okay for now. And if you can think a little deeper about it, please do.